My name is Dag Wanvik. I'm a database engineer with Oracle, and I have been working with the JavaDB technology for the last 5 years. I've been a developer. And the reason why I'm presenting this to you this year, oops, we don't want that, do we? 4 hours should be enough, right? Postpone. Oh, there we go. How do I make that one disappear, huh? Oh, well. Always does things like that, huh? I'm not sure if I'm going to get that to go away, huh?
Push the U button.
I would love to. But the company issued desktop, and it has Windows 7 on it. So anyway, works nice. I'm going to talk about JavaDB today. This is an introductory talk, so if you already know JavaDB intimately well, it's probably not for you. How many know what Darby is, what JavaDB is? Just a hand quick, just to check. Okay, so anybody use it? Another hand? A couple, 3. Okay, that's good. So that's about what I expected. The advent of JDK 7 saw JavaDB actually being a part of the JDK always. We have been shipping JavaDB as an optional component already in JDK 6, but not too many people were aware of that. So we thought we'd take this opportunity to introduce it to a wider audience and make you aware of this little piece of which we find very useful software that's there in the JDK for you. The fact is that this is a small, very useful, powerful piece of software that may well be a good addition to your set of tools when you're developing with the JDK. And we find that people who try to use it are generally pretty happy with it. It's obviously not a replacement for an enterprise caliber database. But it provides you an easy way to get started using an SQL database, or even sometimes something that you could deploy if your needs are on the low side of the data. It does scale up to something like in the gigabytes, but I would not recommend using hundreds of gigabytes on it. But it will do up to 20, 30 concurrent connections, and that added to the benefits it has, which are unique to it, makes it a nice value proposition in many use cases. So I'm just going to, my goal today is just to show you how you can get started with this and evaluate to see if this is something for your company that you want to use. And show how I'm going to do a little showcase using a demo to show you how you can actually use it. And show how easy it is to get started in using it in a sample application. So I'm going to show you some code, so just bear with me, you'll get code. And at the end, I'll also try and cover basically what kind of potential it has, what kind of features you'll see in it, which you may not expect to find in such a small piece of software. Okay, just moving on quickly to availability. Where do you find this thing? As I said, it's shipping in all versions of the JDK currently. If you look at what I've colored yellow there, that would be the directories in the JDK where you can find it, db/lib. There's also a bin directory which has some small tools which you can use to, they are not strictly necessary, but you can use them to start up the server if you want to use the client server mode, and there's also some tools in there, which one of which we'll mention later. Recently, with the announcement of the Oracle Java Embedded Suite, JavaDB will also be shipping as part of that platform. And you may be interested in listening to a talk on Thursday, Con 6684, which covers data storage for embedded middleware, and which will also cover some more advanced use cases for JavaDB. As I said, this is originally an Apache project. We are actually developing the source now in the open source community. So I and other people on my team are actually working in the open source community. when we do develop this. So this is a totally open software. It's free. And currently, it's being rebranded as JavaDB in our distribution. So, but at the time being, the bits are the same. That may not always be the case, but right now, it's the same bits. The reason I mentioned these repositories where you can find it is that if you have a need for debug versions or older versions for some reason, this being a database, it could be useful to get at old versions. You'll find those on the Derby site. Right. Now, once you look into that directory in the JDK or even on the same distribution from Apache, you will see that mainly the physical things that you will see incarnated for Derby is a set of jar files. Now, the main one is the one called derby.jar, which I have highlighted in blue here, that contains the database engine itself. It also contains a JDBC driver that allows you to use this from a Java program in an embedded context. If you want to use the client-server version of the database, I'll come back to that later, you would have to you need some of those other jars as well. And the tool jars is just it contains some of the tools, command line tools that we do supply with JavaDB. And there's a number of jar files covering different locales. So some people maybe we have a number of locales, including languages like Chinese and Japanese. So that would be interesting for some people. The software is being actively maintained, so we do try to keep the regular release early schedule. But this being a database, we do have to consider things like upwards compatibility. So in the community, we typically release one major release of this software every year, and 1 to 2 update releases to cover issues that may crop up or other improvements. What you may want to take notice there is that the minor maintenance releases do not contain any kind of interface changes, so they could be just a drop-in replacement for your current version, modulo bug fixes, whereas the main feature releases could contain things that might force you to change your programs. So that I would encourage everybody to, if you're upgrading, check the release notes carefully. Currently, the version we are shipping in the JDK itself is 10.8.2.2. And it could be the case that, since obviously we're releasing earlier in the community than in the JDK, for some reason, if people are adventurous, they could go and fetch the latest development release to check what's happening in the community. Now, development. I'm going to show you sort of an example application and make that as a running example through the talk. It's a simple password keeper. Everybody has too many passwords these days, so how do you keep track of those? It's a simple GUI application, which I sort of hacked together in a few days. Obviously, the point of this is not to show you a beautiful world class GUI. It's just to show you how you can use the database in a typical and simple application, so to show like the features. But it does work, and I've designed it using the NetBeans Forms Designer. I can recommend that highly, by the way. I never did GUIs myself before. I've been a database hacker, and just took me a few days to get started. So that's a really great way to get started with a GUI, by the way. Now, if you do want to look at the source while I'm talking or later, the bottom URL there will give you the source, including the NetBeans project for it. I will be showing you code, the NetBeans project a little later to see how this all works. But if you want to get kick-started, you can find it there. It's up to you. I'm not sure how fast you can download, but anyway, this application will be using an encrypted database. Obviously, you don't want people to be able to eavesdrop on your passwords, so we want to keep the database, the passwords in a safe storage location. And Darby does have the capability to encrypt data. And we're going to show you a few the typical database operations: insert new ones, update, and query. That's something you get for free. Now, how can this help you develop faster? How can it speed up your development time? I promised you that you can use it to save some time. Well, obviously, you have it there. There's no install step. It's in the JDK already. It's ready to go. And what's more, since JavaDB was designed as a low administration database, there is really no configuration step involved. You don't have to create operating system user accounts, and there's no involved setup procedure. It will run just fine as it is. If you just use it as a library to your application, it will have sensible defaults, although you can obviously tweak them. But in a simple use case, you can use it as it is, and there's no extra setup involved outside adding a jar file to your application, which is nice. Now, you can use it by itself, or you could use it for prototyping and testing your data-rich applications before you move on to deploy this on enterprise caliber database. That's part of the value proposition here. Obviously, if you were considering doing something else than using a database to persist your data, you will get a few things for free, like querying your data. You have SQL, right? So you can always do complicated queries, something which you otherwise might have to code yourself. So that's a time saver. And you get things like export, import. You get a well-defined backup procedure for your data. And you can use it to evolve your data too, and have a controlled process of deploying. Let's say you change the default of it. I have alluded to the fact that Darby can be run both embedded and in the client-server mode. So what's embedded in this case? Well, embedded means different things to different people. And in this case, it does not mean embedded device in any sense, although, as I said, we will be shipping it as part of the Java Embedded Suite. It is actually small enough to go in that context too. But in this context, embedded basically just means that you can run it inside your VM. There's no separate operating system process running your database. It's actually sitting in your VM, which has a number of implications. For one thing, your JDBC calls would not be a protocol step of data going across the network, across the transmission protocols. It will basically be method calls straight into the database engine, which obviously gives you a speed benefit. Now, but no mistake about this. It's not a single user thing. It's still a fully concurrent multi-user database that you're running. So if you're embedded this, say, in something like a web server, you can still have a number of concurrent connections to the database with different user credentials, all running with concurrent processes. It's fully concurrent and scales pretty well, up to at least the low 20, 30 connections. We have done extensive work to try and remove bottlenecks to make it run well in a scalable context. This being a database engine, it can boot a number of databases in parallel. I indicated that with two yellow databases at the bottom. And there's a useful and an extra benefit that since this is all Java, the database is written in pure Java, so you can run anywhere. Even the data are in NDN neutral format, so you can move this around between all your devices. You can ship a database as part of your application that will pick it up and run it anywhere on a different platform. Now, there's also since this is embedded, you can also hide from your end users that this is actually a database running at all. The only thing the user will see is a directory popping up in this file system. So it's a pretty nice way to get database capabilities into your application without the overhead and not to speak of the price that you might normally encounter. But obviously, if you need to scale up, you can move from something like this onto an enterprise database if you're careful and design your schema and your SQL accordingly. Get back to that later. Now, do you need a relational database for small applications like the one I showed you? Maybe not. But then again, it gives you a few things for free, which you may consider. Given the ease of use of this and the fact it's free and it's pretty performant, well, why would you want to forego things like being able to query across your objects? Surprisingly often you start with an application that at the outset doesn't need any query capabilities, but sooner or later people may be interested, oh, we want to query these things and see what's happening in here. Since this is SQL, it allows you to do that. Of course, you get the typical database guarantees, the ACID, atomicity, consistency, isolation, and durability. Although you could, we have modes for running this, which could relax, for example, durability to trade that off for speed. But at the outset, if you design your application using well-defined SQL transactions, that will guarantee that your data is always consistent, even if under a crash. And that's something you get for free using a database. So why not? Well, why do you want to use embedded rather than client server? Well, again, it's a reduced cost. You only use your machine. It may be attractive to the user. He knows all his data is on his own computer. It's not sitting somewhere in the cloud. People are concerned about privacy. Some of us are, although it's getting harder and harder every day. So there's the additional effect that you can change your application from running embedded to client server at any time because these are compatible. You only need to change the URL to start your connection, and that's it. You can move from embedded to client server. That's all it takes. How are we doing on time? Oh, well, 15. Right, let's get back to this application I was talking about, the password keeper. It's a self-contained application. You can ship it with Darby, and it will, let's just have a look at it, see how it looks, so you get an impression what this is. Let's try to run this thing. Where is it? Here. Yeah. This is the dialog. There's actually two dialogues in this. There's a login screen. I just type abracadabra in here to get into my, that will be the key to actually open up the encryption of the data. And you can see you have the application running here. There's a number of, I have an account with Amazon. That will show me my username and my password for that. And I have one at Gmail. Oh, well. So just a few in here. There's a button here to show you the password in clear text in case you forgot. But this just added in case somebody is looking over your shoulder. You don't want the password to show up without you being sure that you're okay. So, and there's a number of buttons at the bottom here. There's an insert button to allow you to insert new records, an update button, a delete record, and there's a query button. So that's basically all there is to it. It will read the database that you specified in the startup dialog, and allows you to look at your data and update them. Oh well, let's just exit that for now. As I said, to get started with this, you just basically create a normal Java application. In this case, I've been using NetBeans to do it. You may use your favorite IDE, doesn't really matter. As long as you specify that you want to use a library, which is the Java, the Darby engine. In this case, NetBeans knows about the fact that the JDK has Java DB as part of it. So it has a library called the Java DB driver or something like that. So you can add it to your project as one of the dependencies that you have. And that's all it takes. You can basically then start designing your application. Darby will be there for you. I promised you, I said I was using this forms designer. This is an example of a screen. How you do that, you have a canvas, basically dragging widgets onto the canvas. And in this case, it shows my startup dialog, which specifies the database name, or the password vault, as I call it here. It's the default value. And the master password to open up the encryption and get this booted. And obviously, there's a connect button, right? So that's all there is. And in this case, you can see I have just designed this by dragging a button from the swing controls here over onto the canvas to get a connect, and that's all. And then the next thing we do is we just basically right-click the button and associate some kind of action with it, action performed in this case, and then the NetBeans will generate the code for me, so I don't have to do all the boilerplate code. So, example here, the gray text you see at the bottom, J button 1 action performed, is the code that's generated for you by the IDE, and the black code is what I filled in to actually get the data from my fields. In this case, I took the password from the password field. Since Swing has a specific password widget, we use that. And I take the database file name from one of the text fields, and I called load database, which is the code we're going to drill into next. You have it here. And now this is where things start getting interesting. As you can see here, the get connection is a JDBC call. This is part of the standard way to access databases in Java. And if you look at the string that I used to connect here, it says JDBC colon Darby, and then it has the name which was passed in, the database name we gave on the dialog. And it has a couple of interesting attributes in this database URL. It says create equals true, and it says data encryption equals true. And it also has an attribute called boot password, which obviously is the password that you use for the encryption in this case. So this does a number of things the first time you run it. It actually startups the Java database engine if it's not been started before. Automatically loads it from the jar files, gets it started. It will open or create, as the case may be, a database by the name that you're specifying here. And it will do so using encryption. And it will return a connection. And that's all it takes. We added the library, we did a get connection, and your database is up and running. So it's kind of hard to beat that. It's not much you have to do, huh? Now, obviously, it's kind of interesting to know if the database was there or not, because we need to put some tables in the database to store our data. So in this case, you see I've extended the code slightly to check if there's a directory by that name. If it is, we already have a database, so we just open it up and go. And if it's the first time we do this, we create the schema for this application, which is a table called credentials, in our case, containing 3 columns. There's just a descriptive ID for it, and there's the username. I put principal in there. I've just been working with security too long. But that's the username. And the password. And that's it. Then you have a connection, and you can move on to the next dialog, which is essentially the main dialog of the application, right? So what I'm going to do first is show you the insert mapping here. Obviously, we have an insert button. Now that's bound to J button 6 when we use the form dialog. So we can do the same thing with this one. I can maybe show you even in the GUI here. Let's see. This is the password keeper UI, and this is the design. I can change between the source view and the forms designer view of this dialog. And it's a bit small here, but I have to drag it down, and you can see my buttons, and you can see the insert buttons here. If I right-click it and go to events and action, let's see if we can do that. It says action performed, J button 6 action performed. So if I click that, it should take me to the insert button, right, in the code, which I have to fill in myself, obviously. Oh well. It is kind of hard to read, so I'll take you back to the PDF instead. Now, what I'm doing here is I'm extracting the fields that you have presumably inserted into the 3 user description and password fields, and inserting those into the database. And to do that, we do something in JDBC which is called a prepared statement. actually you can execute SQL using prepared statement or direct. It's generally, we do prefer to use prepared statements with Derby. I'll get back to that in a second, why we want to do that. But in this case, we have prepared an insert statement, insert into credentials values, and then 3 arguments, the description, the username, and the password. So there's the rest of the contents of that. You see we actually set string 1, 2, and 3 of this prepared statement with the ID, the username, and the password, and we execute this thing, and that's all there is. The data will be persisted, and your database will be updated. In addition, we had a display credentials thing there, which will refresh the list of password in the main dialog, so you can see them popping up there. They're being sorted, so it's sort of, I can probably just show you a simple example of that. Let's run this application again. Okay. Wrong password. Oh, that doesn't do, huh? Oh, there we go. So let's just make an account to, what do you want to do? Oracle Tech Network, something like that. And I put in my name, dog. And a password, just put secret in there. Well, if I was unsure, I can just click it. Oh yeah, I did put secret, that's nice. And we do an insert, and it shows up here. You see it here in, there we go. Right, so that's now persisted to the database. Right. Sorry, that's too quick there. I also show you the similar statements for updating, for selecting, and for deleting from the database. We use, in the application, you'll find those additional prepared statements if you look at the code. Now, I was promising to tell you more about why do we want to use these prepared statements. Well, the way Derby works is that we compile these statements into bytecode. That's obviously an involved process. It takes a bit of time. So it's better to do that once and be done with it, and then use these prepared statements. We don't have to do that over again. Although we do share prepared statements across connections. There's statement caching, which would help you. But then again, since you typically insert values into these statements, in the traditional way of doing that, you would just concatenate your insert string with your values. Obviously, then the statements will look slightly different. So the compiler could not utilize the fact that these are basically the same statements and cache them for you. So it increases the chance of the cache mechanism to actually be able to give you speed to use that. In addition, these days, security. Everybody heard of Bobby Tables, XKCD? Anybody? Yeah. You don't want your users to undermine the consistency of your database by inserting creative SQL at your values. So if you actually use prepared statements, you'll get a real parsing and data type check of the value you're passing in. So if it's not the kind of type you expect, you'll get a slap on your fingers. So it's a good habit to develop. Don't use direct SQL. Although some people in the SQL, MySQL camp will tell you otherwise. It's quick, but I don't recommend it. Try to avoid that. Now, I promised you this gives you query capability for free, obviously. How would you want to do that here in this application? Well, we have 3 fields. So let's say we just want to get all the fields starting with some kind of string. Well, we have the query button. So typically, we would typically then specify just 1 or 2 of these things and see how many of the accounts we had. And since this is a SQL, it will allow you to use wildcards, not regular expressions, unfortunately, at this point, but who knows, maybe the community will put that in. But currently we have these wildcards, which is standard SQL. And you just, we have prepared a statement here to do the query. the more important part to notice there is the where ID-like part. The bottom line there shows you how the query actually looks. We have 3 question marks in there, 1 question mark for each field in the little application. And the like operator is what gives you the ability to have the wildcard in there. It doesn't require that you have exact equality on the string, but it allows you to actually match what you have in there. So basically, then what we do, sorry. This looks a bit messy, I'm sorry about that, but we had to do this differently for the password and the username strings. But essentially, if you have provided a value for that field, we use that. Otherwise, we just put in a percentage sign, which basically is a wildcard, except anything. So that's basically where we construct this simple query, run it, and we take the results. You look at, we do the execute query there. We get back a SQL result set. That's rs equals search credentials dot execute query. And we put that into the underlying data model of this widget, which is the list in the dialog, so that this will display correctly. And that's all it takes. It will display it for us. So that's basically the application. And as you see, there wasn't much to it. We just did a connect, prepared some statements, and that's it. And it gives us a non-trivial application to actually persist data. Now, since this is SQL underneath, we get for free things like importing data from another data source. You wouldn't need to write in your application code to import data. It's a well-defined format. And let's say if you have some data from an earlier password keeper application, if you're able to convert that into CSV file, which is typically easy these days, most applications with a sense should allow you to export your data in some form. So you could convert that into a CSV file, and so since we have an import capability in Derby, it will make it easy for you to just get that in there. So I'm just showing this in this example here. In this case, we are actually using one of those tools I talked about earlier. It's called IJ, and don't ask me what IJ means, but it's our command line tool for doing interactive SQL against JavaDB. And in this case, you can see I'm invoking a jar file, an executable jar file called derbyrun.jar, which is basically an easy way to get set up all the class paths you need. You don't necessarily want to go through the hassle of setting up the class path, so this will just do it for you. You get the necessary libraries. So invoke the IJ tool, and we connect to the database. In this case, obviously, we have to know it's a database there. It's not hidden anymore, but this is a one-time operation. You're just importing data. So as you can see there, I'm basically using the same URL as I did in the JDBC code, except I now have to put in my password so you can read it. It says abracadabra. So that's the same password you'll find in the source if you download and look at it, so you can actually start it up. And we issue a call to import table, and we specify how this CSV file looks, what kind of delimiters we're using, semicolon to delimit the fields, and double quotes to delimit the text fields. And also we are putting an argument to say if we want to append or just replace what's in the database table earlier. And in this case, we just want to append. So we put 0 in there, and that gets our data in there. And that's all it takes. When we start it up, it's there. So we get the import for free. Now, you can also do schema evolution, obviously. JavaDB has the capability to modify tables. And in this case, I just show you a brief example of how you can do that by altering the table to add something like a timestamp to your application. Obviously, if you did that, you would have to go back and recode a little bit of the application to take care of the fact that not all fields would have timestamps. But anyway, it allows you to do that, and in a controlled fashion, a well-defined way. So it could allow you to build easily the application to upgrade the data using this kind of tool. Now, that was development. Just very quick impression of how you can use this or easily. It's also easy to deploy this thing. For one thing, it's licensed. It's free software. It's using the Apache 2.0 license, which is generally considered a very friendly license for people deploying applications. It's not copyleft, so it's not viral in a sense. And it allows you to basically bundle JavaDB or Darby with your application. It's compact. The whole the derby.jar file weighs in at about 2.6 megabytes, which is not an awful amount, awfully large thing when you consider what you get as far as capabilities goes here. You could wrap it up all in an executable jar, like I put in this example, by putting a class path to the Darby jar file, so that will be found automatically. And that allows you to basically zip that thing up in a zip file. And I just put an example of how we can do that using NetBeans, but I won't dig into the details there. It does it more or less for you. And then you basically unzip the file, and you double-click passwordkeeper.jar, and you go. That's it. It's working. So it's pretty easy to deploy an application as part of this. We do support Maven. So if you want to use Darby in a Maven context, you basically just add Darby as a dependency to your Maven POM file, and you should be ready to go. I'm not a Maven expert myself, so I won't say much more about that. But we have, if you're interested, you can always ask on our friendly user list. We have people answering questions all the time. So if you have particular Maven questions, just feel free to come and ask. That's all in the Apache project. Just Google Apache Darby, and we have a number of mailing lists which you can subscribe to, or just basically look at the archives if you're interested in finding things. I think I'll skip this example for now. Just going to say that we can actually ship a shrink-wrapped database along with your application, basically preparing the database and putting that actually in the jar file itself, so that, see, I've indicated the database putting inside a jam jar there to the right. So actually, when you jar this up, we actually include the database in blue there up there, along with the manifest and the application jar. And that makes it easier to distribute databases. Actually, let's say shrink-wrapped read-only databases for applications. Could be sales lists or catalogs or whatever. Makes it easy to distribute that. That's a capability we have, which is kind of nice. And when you access that from the code, you basically change the URL to specify the jar file instead of a file in the file system. So that's pretty easy change, right? Just we changed the protocol there. It says :jar, and then it gives the name of the jar file and the database. And that's all it takes. From there on, if you open a connection and read the data, you're basically reading the data which is in the jar itself. It's kind of neat. Now, I told you I'll try to show you a little bit of, obviously what I've shown you now is just hardly anything. Just insert and delete data, and that's about it. Queries, right? This is a SQL database, so obviously it can do a lot more. Although it's deceptively simple to use, it has some pretty powerful capabilities. And we have on the wiki, we have a sort of a list which shows you the kind of subsetting of the SQL standard that is provided by JavaDB, SQL versus Derby features. If you have a look at that, you'll get a pretty good impression of what it can do, but I'll just briefly mention some of it later. We do run on Java from 5 and up to 7. We support JDBC 4.1, Database Access Standard, part of Oracle. And we are also able to run this on constrained devices running a CDC profile. That's sort of the larger of the embedded profiles. It's not CLDC, but it runs CDC. Hopefully, when we move towards unified SE and ME offering in the future, this will be even more straightforward. There's a number of other standards. We do support OSGI. You can use it as a bundle. You can bundle it up and use it in an OSGI context. We do support using Derby as a part of a distributed transaction. It doesn't control distributed transactions, but it behaves well in such a context. So XA is supported. And now the fact that it's standard, the charter of the open source project is to keep the code base as close to the SQL standard as is practically possible, modulo whatever industry standards develop. We try to be current, so we don't want to be too thickly about it, but we try to avoid putting things in there that would make it harder for you to move your application later to some enterprise database. So we try to stick to the standard, but obviously all the vendors have different, the devil is in the detail as always, and there's things like data types that might differ between the different vendors. So if you plan to port your application or deploy it later to an enterprise database, it would be advisable that you try to aim for a subset of SQL that will work between the two dialects. There we have a couple of tools that will allow you to extract your schema and modify it to run it on another database. There's a tool called deadlock, which basically extracts the schema from the Derby database, allows you to, on a text file, so you can tweak it and put it into another database system. And obviously, you can export your data using a CSV file to move the data across to a totally different system. This is obviously something you need to do carefully, but it's not rocket science. And I think obviously, if that's what you need to do, it can be accomplished pretty easily using some kind of script or something. Now, the engine itself is pretty powerful. It contains typically a lot of the things you would expect from a SQL database. It has transactions, it's multi-user, it supports the traditional ISO isolation levels, it does deadlock detection for you. Obviously, we support the ACID guarantees. And we have advanced features like triggers, stored procedures, user-defined types, table functions, it's a very useful thing. We support collations so that you can handle your locale data in an intelligent way, although presently it's at the database level, it's not at the table level. Something we would like to see is to obviously have that at the table level, but currently it's at the database level. And I won't go into all of these, but obviously have a look at that and you can see that it's pretty capable. We have tried to fit in a number of security features lately. Some of those have been from the outset, other things have been added. For example, we recently added a native user authentication scheme, which is a clear improvement of the existing ones we had. You can also use LDAP, which is probably something many people appreciate, and deploy this in a setting where you have LDAP for single sign-on. We do have encryption of the protocol, obviously, if you use this in client-server mode. We have fine-grained privilege support in the SQL itself, including role support, which is you'll find in most major databases, but not necessarily all of them. We have something called definers versus invokers rights for calling stored procedures, which basically lets you do what in Unix we call a set UID kind of operation. It will escalate your privileges temporarily to run with the privileges of the one that of the user that defined that stored procedure for you, which allows you to basically, of course, solve a number of tricky questions. You don't want your users to access all kind of tables, but you may want them to be able to insert one row, for example. So this is one way you can achieve that. You can use a stored procedure and put the logic controlled in there, so you know that the user is not committing any faux pas. So that's very nice to have. And we have things like conservative file visibility at the operating system level. We support running this in the Java Security Manager. And obviously, you've seen we had encryption on the data and the disk itself. Now, we support running this in client-server mode. In addition to using an embedded version of this, it's as easy as just changing the URL again. You can use the same JDBC code, same application. It's basically, actually, the way it's architected, the network server component that you see running inside the Java VM there actually is using the embedded JDBC driver, which is what you normally use when you use it in embedded mode directly. So it's sort of a guarantee it'll be able to have the same capability more or less. So basically the commands I showed there is just to start up the server and shut down the server. And after that, you connect to the database using this URL, just inserting. You can use, obviously you need to specify machine and port number, but those will also be defaulted if you're running on the local machine. So it's basically just using a slightly different syntax on the connection statement, and you'll be there. In client-server mode, we do run by default under the Java Security Manager, which is something just to be aware of. Sorry?
Yeah, could you also put your database files on a shared volume somewhere?
You could, but that's something we usually don't recommend for performance reasons, obviously. And there's also the question of data integrity. Do you have any guarantees that if you have a log file, do you use a log file to be able to guarantee durability of your data is actually being persisted? Depends on the kind of sharing protocols you have. Do you have a guarantee that the data actually is on disk when you commit? Things like that.
So client server is a recommended way to do.
Yeah, I would imagine instead of putting an embedded one, and yeah. So depending, of course, on your preference. But yeah, if you want to share database, there, yeah. You can mix the two modes. You can have an embedded mode. You see the app there on the left side of the figure. And you can actually have it start up a network server temporarily or at all times to be able to go straight in. You can connect to it using the IJ tool, look at how the data looks. You can fix problems in there. And something happened, you can just go in there to do monitoring to see what kind of data, how large your data is. And you can do that without the main application or even the user noticing that you've been in there looking at it. So that's sort of a nice feature that you can combine the two running modes. Right.
Excuse me.
Yep.
So you're going to say out loud here that if you do this way,
Sorry, I didn't quite.
right? Clusterable.
Clusterable.
Yes. Because back in the other approach I did, this one.
Oh yeah. You can obviously you can use users can access this from a network. You can control if you can only access this from a local machine, or you can access from remote. There's something you can control there. Yeah, and you can also require SSL credentials too. So there's extra security provided there to make sure that you have only validated clients connecting to it. Yeah, so you can handle that too. We can run this in memory mode. If you want to sacrifice durability, and maybe applications where if your data is by nature transient, or you don't really care if you lose some of it during one session, then you can obviously trade this for speed, running it in memory. That's as easy as just adding colon memory to the URL, and the database will just be running in memory. Or you can have a mix of the two, that you sort of read the database when you start up, run it in memory, and then save it when you're done. Sort of like a typical read file, save file at the end of a session kind of thing, which may be useful in some cases. What you would do then is basically just to back up the database when you exit. That would be obviously the persistence step. And then when you want to start it up again, you just basically restore the database from the location where you backed it up to, run it in memory, and keep doing that until you're done. So that's a pretty neat combination. If we do that in our little application, if you look at the source code, you will see that I actually put that in there just to show you how that's done. We just modify our code slightly to you see the URL there. I put the restore from in blue, which basically says that if this database exists, I'll restore it, and I will run it in memory. It says that jar b : memory. So this is actually, we're just restoring the image into memory, running with it, and when we shut down, we do the opposite operation. We back up the database. So you see I prepared a statement there calling backup database, and just give it the directory you want to put it, and that's it. So we've been able to run now the whole application in memory while still saving data. So it's sort of the best of both worlds in some cases. Now, I think I have 10 minutes left, so I'll just basically say that this product has been evolved like any reasonable good code base. It's not something that was invented yesterday. It has a 15-plus year track record. It's being developed actively by people from IBM and Oracle, plus a number of volunteers in the environment. It's a pretty responsive community. And as I told you before, we have a pretty regular schedule for new releases. And so I do believe that we have a proven track record here. And we are very careful not to break upward compatibility, to try to make it easier for people to step up to the new version. But obviously, one does need to read the release notes when moving to a new feature release. That goes without saying. But I think we've been pretty successful so far in enabling users to move with the releases that we provide. Right? Performance, obviously something's got to go, right? This is free, it's a database, so obviously it must be a hog, right? Well, I'm sure you can find databases that are quicker in certain scenarios, but then again, we have this thing, it's in memory, we can do it, that gives you performance, it's embedded, you get rid of those steps across the protocol, and we do use B-trees, we have indexes. So it's a pretty capable optimizer in there. So actually, it does compare. It's up there with the rest of the open source databases, depending on the kind of application data mix that you have. As always, you need to do your own benchmarks to see if it will do for you, depending on the kind of profile your application has. But as I said, we do generate bytecode, and that will be JIT optimized when you get this warmed up. So performance, that's actually pretty good. And we have removed bottlenecks. So scalability is one of the things we like to say that we have at least worked quite a lot on. So try it on and see how it works for you. I put in some performance hints here. I'm not going to go into detail on those. We also have, you can tune the page cache size and to tune the data. So you'll get the right kind of mix of heap and disk, and it does a pretty good job of running in sort of a mode where you can fit most of your stuff in memory, but you need to go to disk now and then. Sort of a mixed operation. It's a pretty good cache handler in there. So, as a summary, it's there. It's easy to use. It's pretty capable. So why not try it out? I think you'll find it'll probably surprise you to do more than you think. So with that, I just want to remind you that we have another session coming up on Thursday. And with that, I open up for Q&A. Thank you very much.